I'm just keen to capture this. I had to do a bit of inference here to try and make some sense out of the plans because of fading, which may or may not be due to the poor reproduction or me just not keeping the plans very well. The number that I was having a problem with was this number, which was barely legible, although actually looking at it, it looked like it was 437. So this is the point where the top of the longeron, it's the depth between the top of the top longeron and the bottom of the bottom longeron. So let's make the assumption that that number wasn't actually available. So that block there is basically the firewall behind the engine, which is this part here. Now the top of the top longeron sits in there, and the bottom of the bottom longeron sits there, and the distance between there and there is, according to this, 440 mil. Now if you look from the side at the top, straightforward at the top, you've got 25 because this is made up of a 15 by 15 plus a 10 plus 15 by 15 plus a 10 by 15, 25, and that corresponds to what's cut into the bulkhead that I have. Now if you come down to the bottom, so 440, where do you get your 437 from? But what you can see is the 440 comes to the bottom of the firewall there, but the idea is that there is a, because the bottom longeron is kind of climbing up towards the firewall, there is that gap there. Well, it's not a gap, but it's a subtle shortening of this length. Now, and that is the 3 mil, I think, that gets you to what I think is 437 millimeters for the front there. And I suppose there is a really straightforward way of working out what that really needs to be by, I can just get past the assorted junk. This isn't junk, this is nicely made stuff, not by me. Here is the firewall. So let's have a look at it. Now, so there we are. That is what I'm talking about. Sorry for the finger in the way. There. That is that's the difference. Sorry. Oh, and again, I'm being useless. Now, is that 3 millimeters? I think it. Let's have a look. Is that 3 millimeters? I think it is. There we go. You can see daylight and then it disappears. 3 millimeters. And down the bottom there, it's butted up there nicely. Wow, that's helpful. Right, let's just double check that. If Mr. I can probably say his first name without destroying his privacy. Malcolm, who sold me this kit, got it right, which I'm sure he did. We should be looking, so I'm going to do this. If I stick my tape up against the top there, what have we got there? Well, as near as, damn it, I reckon 437 millimeters if I position my towards the bottom. That's where where am I? There. Okay, so that's 436, but if one was being imaginative, I think you could say that was 437, is if I put it down against there. Okay, so 437 it is. I'm going after that. Fine, brilliant. That means I can actually crack on with laying this out continue to lay this out. It was a problem because I just couldn't. I couldn't. If I can gesticulate in front of the camera, give a bit of emphasis. I couldn't continue to work my way along the fuselage if I couldn't pin that number down, that one there. It was stopping me from starting at this end and moving backwards across this tricky bit, because I'm not quite sure how exactly I'm going to plot this up, but I'm sure I'll work it out one way or another. Right, that'll do for now. Okay, that was long, 5 minutes, crikey. Okay, I'll stop that. A few issues with the lofting process, really. Just trying to get make sure I've got a right angle, really, because I established last time that this build table is not parallel to that build table. It's neither parallel nor co-axial, although it is coplanar, I suppose. At least in this sense, it shakes across slightly. So I can't rely on the table edge as I was doing over there to give me my right angles. So I'm having to kind of do it. I feel like I'm floating in space a little bit, but I've kind of worked out that I can use these drawing tools initially to try and drop down points that are, so for example we've got 437 here, we established that. So then I'm basically dropping down points 437 according to a right angle given to me by that set square, which is quite small, against the top of the fuselage, and essentially kind of with enough points you can start to build up a picture of how accurate you're being, and kind of sort of through a process of iteration, really zero in on a good accurate position. Didn't really explain that very well. Kind of, I suppose if you're way out here, then you try again, and you'll find this is probably going to be better, and you'll realise that you're way out here, and you can correct for that. And then with another point, assuming that you're still making best endeavours to be at right angles, you should start to find that you're getting a good impression of whether you're on target, on the mark or not. So ultimately I've been doing that to try and, but I want to try and get this bulkhead line accurate. I want it to be an accurate right angle against the top of this fuselage side. It's not the top of the fuselage as such. And so I think I've done it. I've laid out my long rule against the top of the fuselage, the fuselage side, which that's giving me a good registration along there. And then I've positioned this long square against it. I've just moved it now. What an idiot. So if I move that, if I get that back, this is all going to go horribly wrong now. I'll try and keep this right. So I'm trying to position that square on there, and then everything's moved. So my little demonstration is now no good. So I'm getting that accurately positioned there. I've got this long rule positioned properly, and then if I sight along here, that's the line, and you probably can't see, but I think it's, there's an even space between that and the long square. So that to me says this is a very, very close approximation to being parallel with the top of the fuselage side. This has got a nice long section at the top. There's what's the technical term for the right angly bit of a set square? So I'm comfortable that this is well positioned against this, and then this, assuming this square is accurate, this long other long side of the square is looking good against my firewall position. So I reckon that's getting me a good position there. There would be another way to check it, which I'm going to have to persuade myself to do, which is to do a bit of trigonometry. So we know that that's 437, so if we square that, and then if I take another suitable length along here, mark it off, square that, add them together, square root, and then measure the bottom to my point out there. We're doing Pythagoras, and we should get something. If we've got a right angle there, we should get something that is a pretty good approximation to the answer we're expecting. So I better do that now. Okay, I'll do that now. I'm trying to go for slightly shorter videos because I've been just sort of going on and on, I think they're just maybe getting a bit tedious. So I think I'm going to try and do little slightly more bite-sized things. This is probably now up to about 10 minutes, so that'll probably do for now. I'll tell you what, I'm gonna stop this one. I'm gonna do that bit of mathematics, and then maybe just bring you in to show you whether or not I got it right. And then that'll be it for this one. Trying to keep them a little bit more punchy, I think. Okay, see you in a minute. Some maths. Right, 437 squared, 190 is 969. 1,000 squared is a million, of course. 1190, 969 square root is 1091.32. And so that distance, 437, I measured out 1,000 for my meter. So I'm just going to position that. That's pretty much bang on. And then here's my sort of improvised. So that's right on that point there. I reckon that is 1091.3, I reckon. So that makes me feel good. I think that means that that is perpendicular to that. So I'm comfortable that I can use that to project down from the front end of the aircraft. This might be overkill, but you know, it's always worth getting things right because you're going to get enough things wrong. Alright, that'll be that for now. I reckon I'm going to post this, and I'll see you on the next one. Okay, last one, I promise. Struggling as I am with the fact the plans are so faded. I mean, for example, that measurement there, you can see that there's clearly some kind of a dimension there. I can't see anything relating to that on the plans. I'm also struggling to find these what these assembly numbers really correspond to. I can see that they're naming those parts, but I can't find them elsewhere on the plans. But I think that one will probably become clear. But I had this figure here, which is supposed to be the measurement from the nose to this point, where this part, which I think is the seat back, comes down. But I'm not sure if I filled this number in. But these, so the top and the bottom are, I know the camera makes it look like it's curved, but it's actually, they're both referencing the same datum at the front. And if the top of this starts at 1125, it can't slope forward at 10 degrees 30 minutes, or 10.5 degrees essentially, and it can't slope forwards and the bottom be further away from the nose than the top, can it? So I'm not sure whether I filled this number in incorrectly, but I'm not sure. It looks like it's oh, I wonder, 1125, 1133. Oh, you know what? I wonder if that's it. So what's happened, I did a bit of trigonometry, right? And I know this length because it's marked, and I can actually see that they've got a line projection from there. I'm pretty sure it's there to there. So that's the length from here to here, 449, and the angle on this part is supposed to be 10 degrees and 30 seconds. 10 degrees and 30 minutes of arc. So bit of maths says that if that's 449, 10.5 at the top, then our opposite should be 81.8. Now here it is. So yeah, so this should actually be, if that is 1125, this should be 1043. But being a bit, so 1125 to 1133 is 8 millimeters, and the reduction is, near as damn it, 80 millimeters. Could it be that the person who drew the plans just cocked up they didn't cock up the maths, but they got it out by a factor of 10 and added it rather than subtracting it? Because that should be, you know, you're subtracting that 8 millimeters rather than adding it. So you go down rather than up, as they've done here. Now I'm starting to doubt myself whether this is really 81.8 or whether it is 8.1. But 10 degrees of slope is a fair amount over 449 mil. God, it's not 4 minutes again. Christ, okay, I better stop. Hold on. I'll stop and I'll go back and have another look at what I've done. Okay, well, I'm not sure whether I've managed to explain what happened, but something's come unstuck somewhere. So what I've done is I have, as I say, I worked out what I thought the distance between a vertical projected from here across to here should be, which is 81.8 mil. Using trig, I know what this length should be, so I set up my ruler, my rule, long rule, 449 mil, found the right spot, which is the right distance from the front of the aircraft, 1043 mils. And then if you look at my set square, my crappy set square that is not really up to the job, that is 10.5 degrees, 10 minutes, 10 degrees, 30 minutes off vertical. So this is hard. This is harder than I was expecting. Focus. This is harder than I was hoping it would be, but I think that that's okay. I think I'm happy with that. That location corresponds to a very hard to see location on the plans. I think I'm going to have to speak to give engineering a call at the LEA and see if I can get them to just reproduce maybe this part of the plans, because it's just so faded. I mean, that there, you know, it's gone. I think I know what it is. This is 15 by 15, and that to me I think is 10 by 15, but it's just gone. Whether it's my fault or whether, I know the plans were pretty ropey to start with. If you look at some of the reproduction, like this page, it's you know, if you look down here, like, you've lost huge amounts of the, and up the top here, I mean, I don't know how they were reproduced, but you know, you've lost quite a lot information here. Fortunately, you can work it out from looking up the part. 140. You've still got that, fortunately. So in that instance, you can look up the part. But I'm finding that I'm having to do quite a lot of. It's not guesswork. It's more just triangulation, really, to try to get back to a result. 2 minutes, 2.5 minutes. God, shut up, Will. But it's frustrating. It's a headache. Actually, genuinely gives me a headache. Why this number is different from this number? I must be missing something. It must be something. I can feel. It's the sort of mistake I would make. Something's been added, when it should be subtracted, or vice versa. 8s and 3s. No, they add up to 5s different. You know, and there's a lot of 5s going on in this design. So I just think something's come unstuck there, but there's probably some other reason why I've completely got it wrong. But yeah, who knows? I'm going to have to speak to engineering and see if I can work out what it is. So I'm going to have to pencil this stuff in, which is frustrating because it's difficult enough to progress as it is without having to wrestle with not really understanding what's going on here. But I'll stop moaning now. Okay, alright, definitely that is it. I'll see you on the next one.